Alright, let's look at the homework 7.4, 7.5, problem number 9. Alright, let's see if we have these four different second partials. Let's do a couple of these since it seems redundant to do all of them. Alright, so let's do that. Alright, first, I don't like square roots, so I'm gonna just go ahead and rewrite it as quantity 36 minus x squared minus y squared raised to the 1/2 power. Alright, so we have to find the first partial. So let's take the partial derivative of z. Let's do it with respect to x. Alright, so this is chain rule. So first, outside is 1/2 power, so it's a power rule. 1/2 in front. Keep the same quantity, 36 minus x squared minus y squared. Alright, then subtract 1 from the power, so it's a negative 1/2. Then multiply by partial derivative of the inside with respect to x. Alright, partial derivative of 36 is 0 since 36 is a constant, and a partial derivative of negative x squared would be negative 2x, and a partial derivative of negative y squared with respect to x would be 0 because y is considered to be a constant. Alright, then we can just clean it up a little bit, so we can cancel 2 on top and 2 on the bottom. Alright, then you would have, so this is going to be x over, actually it's a negative x, maybe I'll put the negative sign, actually negative sign in front. Alright, then you have a negative sign, so you have a quantity 36 minus x squared minus y squared, and the 1/2 power is square root. Right. So this would be the first partial with respect to x, and let's do a partial with respect to y too. So it's very similar. Partial with respect to y. Right. Then same thing. So 1/2 in front. Keep the same quantity. 36 minus x squared minus y squared. Raise it to the negative 1/2 power. Subtract 1 from the power. And a partial derivative of the inside with respect to y would be derivative of 36 is 0. Partial derivative negative x squared is 0 because x is considered to be a constant. And partial derivative of negative y squared would be negative 2y. Right? So just like before, we can cancel 2 on the bottom and 2 on top. And then you end up getting negative y over square root of 36 minus x squared minus y squared. Alright, so let's do let's do the last, second one, maybe the last one. Alright, let's do this guy right here, and this guy right here, and this guy right here. Alright, so this means that we already take the partial with respect to y first, so we take that, and take the partial with respect to x. Alright, so let's do that. So this notation, second partial of z, right, with respect to y first, then you take the with respect to x. Right, so this is really the partial derivative with respect to x of this guy right here. Alright, so because partial with respect to y, we just found it here. Alright, so I'm gonna write it this way. So let's see. Alright, there's a negative sign and there's y. Right, I don't like square root on the bottom, so you have 36 minus x squared minus y squared, right? And since it's sitting on the bottom, so it's a negative power, and a square root is 1/2 power, right? So we have that. Alright, so since this is a partial with respect to x, this guy right here, negative y, is actually just a number, so you can actually kick that guy out. Right? So I'm gonna do that here. So you have negative y just in front. Right? Then we worry about taking the partial derivative of the rest of the expression. Right? So let's do that. So partial derivative of that would be put negative 1/2 in front. Right? Keep the same quantity, so it's a 36 minus x squared minus y squared, and subtract 1 from the power, so negative 3/2. Then multiply by derivative, partial derivative of this guy inside function with respect to x. So that's negative 2x. Right? So we can cancel. Right? So negative 2 on the bottom and negative 2 on top. We can cancel that. Then we end up getting, right? So this is going to be, let's see, I'm going to go down here. Right? So x is on top, and there's y in front there, and there's a negative sign there. Right? And on the bottom, since it's a negative power, I'll put it on the bottom. Right, 36 minus x squared minus y squared raised to the 3/2 power. Right, so let's type this guy in first and see if we got it. Right, so we have, right, this guy we found that to be negative, right, xy over square root, not square root, sorry, and that's, let's see, backspace would work, maybe not. Alright, so that would be parenthesis raised to the 3/2 power, and you have a 36 minus x squared minus y squared. Right, so let's check the answer here. Submit for testing. Alright, we got this one. Alright, so let's find the second partial with respect to y. Alright, so second partial with respect to y would be, we take the same guy, but we have to take the partial with respect to y again. So here, y, right? So this is really this partial with respect to y. Right, and then well, actually, can I do the first one, because this way I'm wasting partial derivative with respect to x. So let's do this one instead of that one. So that'll be a little bit more interesting. So let's do it that way. Right. So let's say if you want to find the partial of z with respect to x, right? Second partial, right? So that would mean that we have to take this partial derivative with respect to x of this guy right here. So I'm going to put it negative x over, right, square root. If you don't, I don't like square root, so I'm going to write 36 minus x squared minus y squared to the 1/2 power. Alright, so let's use the quotient rule on this one, because we're taking the partial derivative with respect to x. Alright, so what you're going to get is, let's see, there's a negative sign here, put that there. Alright, square the bottom, so that's easy. 36 minus x squared minus y squared. Alright, take the derivative of the top, which is 1, times the bottom, 36 minus x squared minus y squared raised to the 1/2 power, minus, right, top is x, times the derivative of the bottom, and which is actually shows up right here, but I'm gonna go ahead and do it. So it's a 1/2 in front, and 36 minus x squared minus y squared, right? Subtract 1/2, 1 from 1/2, so negative 1/2. Then multiply by partial derivative of this guy, so negative 2x. Right, then we need to clean up a little bit. So you have a 2 here and 2 on the bottom, and a negative sign, so we turn that into negative sign, so that's going to be a plus sign. Alright, then what I want to do is, I don't like to have a negative power like negative 1/2. I'm going to multiply top and bottom by quantity 36 minus x squared minus y squared, raise it to the 1/2 power. So you do the same thing on the bottom too. Right? So what you get is, this is going to be, right, so there's a negative sign already still there. Right, so you have, let's see, so you have this guy times that, so it's a 36 minus x squared minus y squared to the 3/2 power, because the first power and the 1/2 power combined. So we got that. Right, so if you distribute this guy to the first term, right, so it's actually 1/2 power will be gone, so you're going to end up getting 36 minus x squared minus y squared. Right, then if you distribute this guy to the second term, and this guy actually cancel out, so what's left is going to be plus x squared. Right, so you have a plus x squared. Right, so we can cancel minus x squared and a plus x squared there, so we end up getting negative. I'm going to actually distribute the negative. So you're going to get y squared minus 36 over 36 minus x squared minus y squared. Alright, so to the 3/2 power. Alright, so let's type it in. So it's going to be a fraction, and y squared minus 36 over quantity, raise it to the 3/2 power, 36 minus x squared minus y squared. Alright, so let's check the answer. Submit for testing. Alright, it came back, and looks like we got this one correctly as well. Alright, that's it. You can do the other two very similarly, so I'm going to let you work it out. Alright, that's it. I hope that this was clear.